years or so that I've been involved in doing this, one area which has improved considerably is the ergonomics of the operators' cabs on very large surface mine equipment, haul trucks and so on. The internal ergonomics of these cabs has made a significant improvement. There's still problems, ergonomics problems outside, and just to mention one in passing, we noticed on one haul truck that the brake lights seemed extremely small. So we measured the diameter of the brake light and we measured the overall height of the machine and calculated the ratio of the brake light to the overall height of the machine and then applied it to a car. And what would happen is if you had the same ratio of brake light to overall height, the brake lights on your car would be about the size of your thumbnail. So once again, there is a potential for concern. Moving on to environmental issues, we were asked to investigate or re-investigate an accident in a heavy machinery shop, repair shop on a coal mine, where a man had been killed after being hit by a reversing forklift truck. Now, he was in a position where theoretically he should not have been, and his training should have proved that he shouldn't be there because that was an area where the trucks did reverse. It had been proven during the initial examination that the reverse warning was absolutely sound. There was no problem whatsoever. As soon as you engaged reverse gear, the warning started. So that was fine. The conclusion that was drawn was that this accident was due to poor personal positioning by the man. The trade union involved asked us to re-examine this because they thought this was a little bit unrealistic and unfair. And what we noticed was, because it was a very, very noisy environment, everybody wore hearing defenders, and they were very good at wearing hearing defenders. They really did do as they were told and use their PPE. But what we discovered when we examined the hearing defenders was that the attenuation was so high that it completely masked the warning signal. What we had here was a very good occupational health provision, which was actually creating an occupational safety problem. I'm getting behind on my slides. Another example is a situation where we were looking at some jobs involved working in heights and demolition exercise on part of a worked out mine. And we noticed when we were doing this that a man was spotted wearing his safety harness upside down. He had his arms through the leg holes and his legs through the arm holes. I rang up the manufacturers of this safety harness and said, what happens if he fell and he had the harness on upside down? He said, without any hesitation, he said he'd break his neck. So I asked the guy himself why he wore his harness this way around, and the reason is at the bottom there. He said it's much more comfortable if I wear it upside down. So I tried it on. I put it on the right way up, and then I put it on upside down, and he was dead right. If you wore it the right way up, it created some serious problems in rather delicate parts of the male anatomy. So we have a question here, like some of the issues I've given earlier. Question is, who's responsible for the fact that this guy isn't wearing a safety harness? Is it the guy who is ignoring his training? This guy he went for his annual refresher training, and every time he did that, he put it on the right way up. He knew the right way to wear it, but it's when he left there, he put it on upside down. So is it his responsibility for inappropriate behavior, or is it the responsibility of the designer for designing such an incredibly uncomfortable piece of equipment? The next level in my multicolored diagram was codes, rules and procedures. And codes, rules and procedures are essentially the instruction manual of a safety management system, and at that level they are crucially important. This example comes from a hydrofluoric acid plant, some work that I did outside the mining industry, and they just had a new computer system installed. And I'd been in there 3 or 4 shifts, 5 shifts, and I suddenly realized that this warning, standby pump not working, was on the alarm line of the computer screen, and it was there all the time. And eventually, after seeing this permanently there for 3, 4, 5 days, and thinking, hang on a minute, that's not an alarm. The standby pump should not be working. So that's actually a description of a real circumstance. So I said to the guy, what does this mean? And his answer was super. His answer was, I have no idea what it means, but it can't be important because it's always there. So we're in a situation here whereby he's getting so used to ignoring parts of the alarm screen that he's actually in grave danger of getting to the position where he doesn't actually take a real alarm seriously. One mine that I worked at some years ago was concerned about the fact that there was a number of minor incidents occurring on the underground locomotives. So what they decided to do was to create what they called a loco driver's defects book. If the driver was concerned about any aspect of his locomotive when he came out at the end of his shift, he entered this down in the book. And the idea was that the mechanical engineers and electrical engineers who were coming on the next shift would look at this, go down and see what was the problem and see if it needed any exercise, any action. So when we looked at this book, we noticed that one entry was made by a driver after the Monday morning shift. The same entry was repeated on Tuesday, and on Wednesday, and on Thursday. On Friday, there was a different entry. And where those asterisks are, you put in any swear word you want. It'll do. Right? What he said is, why doesn't anybody read this book except me? Now, when we spoke to the engineers, they had in fact gone down and seen his locomotive, but he decided there was an issue, but it could wait until Saturday when they had their maintenance shift. But nobody told the driver. So we've got a nice little simple system here which could do a lot of good, completely destroyed. That driver is never going to use that system again. He doesn't believe it. Nobody takes any notice of him. And it's that kind of thing that not only affects this book, but it's that kind of thing which affects the safety culture as well. On the entrance to the workshop in one mine, it's had this sign. Smoking regulations apply here. Now in English, depending where you put the pause, that can mean two totally different things. It can either mean that smoking is not allowed, or it can mean that there are no smoking regulations, don't apply here. So even with just a few words, you can create a situation where you can cause confusion. Moving on to the next level relates to training and competence. And what we've got here is, if we take a first example, manual handling, back pain, one of the biggest lost time, sickness absence issues in every industry, in every country. Right? It's also one of the areas where we devote more time to training than anything else. We're constantly training how do people to lift. And the majority of that training concentrates on kinetic lifting, which is the two mantras: lift with your legs, not your back, and lift with straight back and bent knees. Right? We all know it, we've all heard of it. We all know it makes good biomechanical sense, because a muscle is roughly proportional, the strength of a muscle is roughly proportional to its cross-section. And the cross-section of the muscles in your leg is much bigger than the muscles running down your spine, which are about that thick. Right? So it makes biomechanical sense. It's a good way to teach people, except they go out of the training room and they, in 5 minutes flat, find a situation where they can't actually do it. And if you want a good example of that, try lifting out of a car trunk without bending your knees and keeping your back straight. It can't be done. Well, actually, with a bit of imagination, it can be done. There's a mechanical engineering solution. And there's also an Olympic gymnast solution. Right? But they're not really practical. You wouldn't go around advocating your miners to stand on their heads in order to lift something. But the point is that if you go around telling people things in a training room, which actually they soon discover are not practical, they're theoretical, they might be good in an ideal situation, but they don't work in a mine. It reduces the credibility of the training, which again, as I hinted earlier, is something which will reduce the credibility of the safety culture. I want to move from a rather trite, perhaps a little bit silly example, right the way through to the opposite extreme, to a quotation that I've taken from an investigation into an explosion at the MINERA No. 2 mine, coal mine in Queensland. Part of the official inquiry said, as demonstrated repeatedly in evidence, should not be taken for granted that the statutory certificate of competence to practice as a mine manager, an under-manager or deputy carries the assurance that that will always be adequate. Now, we train people up, they get qualifications, they get their degrees, they pass out their certification for a mine manager. What happens then? Nothing. They then go for another 20 or 30 years on the assumption that they don't need to learn anything else. It was clear in the explosion at MINERA No. 2 mine that most of the senior management in that organisation had failed to complete their duties. So we not only need to think carefully about how we train our miners, our workforce, but we actually need to think whether or not our junior managers, middle managers, senior managers, even the very top of the organisation, occasionally needs to have some information presented to them which they can utilise for the benefit of everybody. Moving on to supervision and management errors, there was a situation in a coal mine in South Africa that we worked on where there was a first-line manager who was responsible for one coal face. The road leading up to the face, the long wall face itself, and the road leading back from the face. The mine decided that it was a good idea to make that one manager responsible for 2 districts instead of just the one. Now, this looked perfectly sensible whenever they examined it, except for one thing which concerned them, and that was that there was a specified periods when they had to take methane readings, because it was a fairly gassy mine. So the question then arose, how can you assure that you're in District A when District A's methane readings are required? You might actually be in District B. So what they decided to do to avoid this was to train the machine driver in each district with taking methane and recording methane readings. When we looked at how this was working, we were astonished because for 3-4 weeks, 3 shifts a day, the methane reading was 0. And this mine was, as I said, a fairly gassy mine. There was no way that that methane reading could ever be true. When we went down and looked at the districts, what we discovered was that the machine drivers who were responsible for taking these readings were religiously carrying out, when they had to do them, they did them and they religiously recorded them. But what they'd done is they'd hung the methanometer, they'd hung the instrument over one of their control panels, and it was directly in the line of the fresh air coming into the district. So that methanometer was never going to read anything other than 0. And what happened here was when they had done their decision about how they would transfer this information and they'd done the training needs analysis for the machine driver, they forgot to mention the importance of where that reading was taken. But perhaps even more important than that, in this context, in the context of which I'm talking, perhaps even more important than the fact that they put it in wrong phase, was the fact that for 3 weeks, nobody among the supervisors or the managers had ever looked at those recordings. Because if they had, they'd have realised it was wrong. So we have a known gassy mine where nobody's taking methane readings. The potential danger is enormous. Go ahead of myself again. We did a study some time ago of electricians and permit-to-work systems. There are a number of concerns about people being injured, particularly burns to the hands, where it was apparent that they hadn't fully followed the permit-to-work procedure of identifying how to isolate, what needed isolating, the process you go through to isolate, have an official sign it off and so on. So when we began to look at this, we looked at whether how managers perceived the permit to work system, how the supervisors did and how the electricians themselves did. And what became apparent was that both the managers and the actual electricians thought that the permit to work system was crucial to safety. The supervisors considered it to be either a waste of time or impractical. So we've got a situation here where the people who were supposed to be monitoring the careful use of this permit to work system were the ones who thought it was a waste of time. So you can understand how pressure came on from the supervisors to the electricians to get along with it, because as far as the supervisors concerned, this was a complete load of bureaucracy. And to confirm that, what we found, and this was a complete accident, we literally tripped over it, what we found was that at the start of the shift, the supervisors sat in the corner and signed off all the permit to work systems before they'd even started any of the work. So the actual paperwork trail was superb, but nobody was doing the job. I want to slip away from mining for a minute and give you two quotes from some major disasters which occurred in the UK. The first was the King's Cross station fire on the underground on the metro, where 39 people were killed. In the official report to this, it said no one person was charged with overall responsibility of safety within the London Underground organisation. Each director had a belief that he was responsible for his own division, but that principally covered the safety of staff. Several different directorates who could have been responsible for the safety of escalators where the fire started were of the assumption that somebody else was responsible for it. The safety staff believed that their responsibility only extended as far as the staff of the company. And it became apparent, looking at the organisation of the safety, that nobody, literally nobody in the organisation, with about 15, 20,000 people, had any charge, any responsibility for the safety of passengers. They moved several million passengers a day, and nobody in the organisation had that responsibility. There were a whole host of safety people associated with the safety of staff, but nobody looking at the safety of passengers.